Okay, this is section 5.1, exercise 11, in which you're asked, draw a Venn diagram for each of the following situations. So A, B, and C are subsets of some universal set U, and we're supposed to sort of draw Venn diagrams that illustrate the particular relationships that are given in each of these parts. So we'll look at two parts of number 11, 11b and 11c. 11b, the condition they want us to illustrate is A intersect B equals the empty set. And so C is not even part of this particular condition. So we can include C if we want to, or we can leave C completely out of our diagram. Maybe we'll include it just for completeness here. But this is only a condition on A and B. And for their intersection to equal the empty set, we know this is just the definition of what it means to be disjoint. So A and B have nothing in common. Their intersection is empty. So in terms of a Venn diagram, if we want to maybe draw our universe, A sits inside of our universe, B sits inside of our universe, but with the condition that it's disjoint from A. So however we draw B, we just have to make sure that it does not intersect the set A. If we want to include C, there's no conditions on C. And so to give a completely general Venn diagram, we consider the fact that, well, C might overlap with these sets, and it might not. We just kind of leave C as a very general arrangement. All right, for part C, 11 part C, we have a longer list of conditions that are satisfied. So here's our universal set U. Let's just list these off. A is not a subset of B, and B is not a subset of A. That means A and B may have something in common, but neither one of them sits completely within inside the other. So this just refers to sort of a very generic position like this. We're not assuming they're disjoint, but we're neither assuming that one is completely inside the other one either. They might have some in common, like these two do, or maybe not. The last two conditions are for the set C, our third set. It is supposed to be a subset of A, but not a subset of B. So it needs to sit completely inside of the set A and not completely inside of the set B. So for example, this would be a wrong thing to do to make that our set C, because that's now sitting inside of A, but it's also sitting inside of B. So get rid of that. We want to see maybe something like this. So that C is completely inside the set A, but it's not completely inside. Doesn't mean it can't overlap with B, but it's just not completely inside of B.